Imagine a world where humans and robots live next to each other. Robots can see and feel their environment and get into direct contact with it. They are able to assist humans and choose their actions safely. The next step towards this goal is to enable machines to leave their life behind fences and work together with their human creators. This video shows our efforts in interaction control and planning for achieving human-friendly robot co-workers. Our goal is to enable machines to intuitively and safely assemble workpieces together with human workers. Typically, such a task consists of the following subtasks. First, the parts arrive at the workspace and are sorted into storage units by the robot. Then, the human assembles the product with parts provided by the robot and places it on a conveyor belt. Our joint assembly planner works as follows. After assembly instructions are automatically converted into an abstract assembly plan, a joint action plan is created by an interaction planner. It expresses the respective actions and interactions of humans and robots. It also takes into account each agent's capabilities and availabilities, optimizing for task-relevant criteria such as human safety or cycle time. As a concrete implementation, we choose a toy train track assembly, which is comparable to industrial assembly tasks in terms of complexity. The setup consists of 2 robots, a multi-camera system for detecting humans and objects, and interactive displays visualizing relevant task information. Starting the task is triggered by pushing one of the robots down. Our robots are able to feel and interpret such haptic gestures. The positions of the tracks are determined by a 3D machine vision system. Making robots as compliant as humans enables an otherwise stiff and clumsy machine to sensitively manipulate the world and open doors as easily as humans do. In order to robustly pick up objects or place them into storage, the robot employs its sophisticated sensing capabilities. The key to success is to take inspiration from the human, combine visual and tactile perception whenever possible. After the task is completed, the doors are closed and the robots return to their sleeping mode. The human selects a track to be built, and the according joint action plan is generated and executed. In order to avoid jamming, the robot moves with human-like compliance. In other words, it lets itself be guided by the environment. Using a light haptic gesture, the human tells the robot to hand over the part and therefore controls the overall task progress. A projection on the table ensures that the human is always aware of the robot's internal thinking. The robots are capable of distinguishing contact intensity. Gentle contacts are interpreted as the humans intend to interact. This makes the robot pause and wait for further input. The system now offers various interaction possibilities such as opening and closing the gripper or switching to gravity-free mode. The robot is light as a feather and can be positioned freely by the operator. To continue the task, the human just gives the robot a slight tap. In case of collisions, which the robot interprets as undesired and possibly dangerous, the task cannot be continued due to safety concerns. However, it may be restarted once the operator confirms the safe state of the environment through another haptic gesture. Further interaction possibilities with the system are gestures which allow the operator to start and stop the robot in its task.